Okay, here we are in extension 1.3. We are going to be solving some absolute value equations. This is where the real taste of algebra comes in. This is definitely some new material. So you have a fill in the blank here. It says a blank is an equation that contains an absolute value expression. It is an absolute value equation. So you want to write that down. Here are 3 examples of what an absolute value equation looks like. Now, if you remember, absolute value is the distance from 0. Okay, so we can solve these types of equations by solving 2 related linear equations. So looking at the key idea, let's see, I don't know if I want to mark anything or not, but we have the absolute value part here and equal to C, right? These are all letters and just generic, but C is going to be greater than or equal to 0. So remember that we're talking about distance from 0. So this value right here cannot be negative. The absolute value, the distance of something, is always a positive value. However, what's inside of the brackets, inside the, I call them like field goals, whatever you want to call them, the absolute value symbols, technically, that can be negative, right? Because when you have a number line, you have 2 sides of 0. You could have 3 and its opposite, -3. And how far away from 0 are they? They're both 3 units long. So in this case, that C would represent, the 3, the distance from, 0, which in this case would be what we're talking about. So let's look at some examples. All right, so if we're going to solve this equation, we have, I'll point out a few things here. So x minus 4, the absolute value of x minus 4 is equal to 6. So the absolute value of something is 6. That means it's 6 units from this point or wherever we're talking about, right? So this is the distance from this halfway point, right? So we're going to have 2 numbers, 2 answers, 2 solutions that we're going to graph. And so this is the distance. Okay. This number 4 would be the actual halfway point. It's going to be halfway between these 2 solutions. Okay? Because if the value of this inside the brackets is positive, right? It's going to be, x is going to be one thing to make it equal to 6 units from 4. If it's negative, it still has to be 6 units from 4. So let's take a look at that. So we just take the inside of the bracket, right? The x minus 4 expression equal to 6. Or we take the inside of the bracket, right? We got rid of the absolute value bracket, and we want the inside to be equal to a -6, right? Not the outside, the inside. We're adding 4 to both sides either way. We could get that x is either equal to 10 or x is equal to -2. So if we were to graph them, like they're the extremes, they're the minimum. This would be the minimum value. And this would be the maximum value. 2 different extremes, right? But notice that the 6 is how far away the maximum number 10 is from 4. And again, 4 is that halfway point. It is halfway between 10 and -2. -2 is 6 units away. That's the distance it is, because the symbol is telling us that the distance from 4 is going to be 6 units. We don't know what x is going to be equal to in order to make the expression inside of it true, and it's going to be -2 or 10 for x. Okay, so I know that that's a little bit confusing because you haven't done this yet. So we're going to be working on this. So let's take a look at some examples. Okay, so in this case, the first example, right, the absolute value of x is equal to 10. That means that the distance is 10, right? So what values of x would have a distance of 10? Well, it would be 10 or -10. There's no expression. So x could be equal to 10 or x equals negative 10. Because if we had 10, the absolute value of 10 is equal to 10 because it's 10 units from 0, or the absolute value of negative 10 is equal to 10 because it's 10 units from 0. Okay? Okay, let's look at number 2. Number 2. So we want to find out what the minimum and maximum is for x, right? That'll be 4 units from 1. So we want to solve x minus 1 equals 4, or we can solve x, and we are going to solve both, right? But the other value would be negative 4, okay? Because inside the bracket could be a value of a negative 4. If x minus 1 is equal to negative 4, this would also be positive 4. That's what we're solving. So we add 1 to both sides. So we get x is equal to 5, or we add 1, x is equal to negative 3. And I forgot to graph the solution over here. So when you're asked to graph, if you're doing it online on Big Ideas, it'll probably give you some kind of a number line, but you just want to graph it as such. All right, for here, let's see, that's 0. That'll be our 5. That'll be our negative 3 for some reference. So negative 3 and 5. Okay. All right. And if you look at this, for the first one, notice there was nothing in there, x plus 0, minus 0, whatever. Here, minus 1, it's 1. We've shifted the distance from, it's going to be 1. It's right here, right? And it's 4 units would be 5, and 4 units would be negative 3. So the center point now went from 0 to 1 based on this equation. Okay. Here we have 3 plus, the absolute value of 3 plus x is equal to negative 3. Doesn't matter if that's 3 plus x or x plus 3 because addition is commutative. What does matter is right here. The distance from something, whatever it is, can never be represented as a negative number. So this has no solution. All right, because the absolute value would not be a negative number. Okay. Last is number 4. The absolute value of 4x minus 5 is equal to 8. And if you notice, I'm doing all of these because they are all so new, just to give you more explanations and more examples of watching them being done. So we're going to solve 2 equations. 4x minus 5 is equal to 8, or it could also be equal to 4x minus 5 equal to this negative 8. So again, this is a 2-step equation now. We're adding 5. So we get 4x is equal to 13. So if we divide by 4, we get x is equal to 13 fourths. Or we add 5 to a negative 8, and we get 4x equals negative 3, and we divide by 4, and we get x is equal to negative 3 fourths. So I'm going to graph that over here. So right next to a little bit bigger than 3 is our 13 fourths. And negative 3 fourths is about right there. Make sure that looks like a negative. Okay, so you have to do your best, and I know it's very sloppy, so I apologize for that. Apologize for sloppy. You need to pause and write that down or whatever you need to do, but I'm going to go ahead and clear it now, so I just want to give you a heads up. Okay, we will also be watching this video in class because I'm having difficulty getting them to play within this embedded video. Few more examples. All right. Sometimes we'll see these equations and they're not just the absolute value symbol. So you always want to isolate the absolute value symbol before you're ready to do your two equations. So here I have this absolute value of negative x minus 2, and then I have this plus 5 equals 9. So we're first going to subtract 5 on both sides so that we can then get the absolute value of x minus 2 is equal to, so that cancels, 4. So now we're ready and we have it in shape. We can do x minus 2 is equal to 4, or x minus 2 is equal to negative 4. So we add 2, x is equal to 6, or add 2, x is equal to negative 2. And these are your two solutions, no need to graph them, okay? Looking at number 6, there's nothing to add or subtract, but this 4 right here, right? We don't want to distribute it, but we do want to go ahead and divide both sides by 4. That'll help us get rid of it. Okay, then we could have our 2x plus 7, ooh, that's very sloppy, is equal to 4. So now we have our 2x plus 7 is equal to 4, or 2x plus 7 equals negative 4. Okay. All right, so again, we're just solving away here. Subtract 7. We have negative 3. We're going to divide by 2. So for number 6, we'll have x is equal to negative 3 over 2. Okay. Subtract 7, 2x is equal to negative 11. Divide by 2, divide by 2. Or x is equal to a negative 11 over 2. Okay. Looking at this one, we have a whole lot of stuff going on. It does say a negative here, but let me first get it into shape first. Only reason I'm saying that is because I know that if I divide a negative number by a negative number, I get a positive number. So first I want to, undo this by adding 3. Right? So we'll have this negative 2, absolute value 5x minus 1. And that's gone. And that's equal to negative 8. And then remember, I can divide both sides by this negative 2 to get rid of the negative 2. And now all of a sudden we have a positive number. So we have the absolute value of 5x minus 1 is equal to 4. And that's one we can solve, right? Because we can solve 5x minus 1 is equal to 4, or 5x minus 1 is equal to negative 4. Okay? So I'm going to go ahead and make a multiple choice question. You let me know what the two values of x are, even though I've worked it all the way to that point for number 7. Okay, and you can just finish that problem. All right, looking at number 8. Write an absolute value equation that has 5 and 15 as its solutions. Now, these are what we're going to talk about as those minimum and maximum values, okay? So the first thing you're going to want to do is find what that halfway point is. So 5 plus 15 divided by 2, right? That's going to be equal to 10. So our halfway point is 10. If you can recall, or look back, in your notes, or well, I don't know if I had you write it down in your notes. The way it's set up is you have your x minus your halfway point, okay, inside the absolute value points, and that's going to be equal to the distance. I think I put it in the example from the book. Distance from the halfway point. Okay, so if our halfway point is 10, it would be x minus 10 inside absolute value symbols. X minus 10. Now, how far away is 5 from 10? It's 5 units, right? How far away is 15 from 10? Also 5 units. That's what goes out here. Okay, so our distance from 10 is 5 units. It could either be 5 or 15 as our solutions. Okay, So the poem contest is kind of the same. We have a poem contest with a minimum length of 16 and a maximum of 32. So that's your minimum and maximum. So you have 16 plus 32 divided by 2. So that'll give you 24. So your halfway point is 24, right? X minus 24. Well, how far away from 16 is 24? How far away from 32 is 24? The answer to that goes right here, and it's 8. So x minus 24 is equal to 8 would be an absolute value equation that has those minimum and maximum lengths. Hopefully that was helpful. Okay, that is the end of the video. See you in class tomorrow.